So in case of Prussian blue, which one you feel that it is existing correctly? Iron 3. So only the option says iron 3 and iron 2. Iron 3 exists as high spin or iron 2 exists as low spin. Which one option is correct? So firstly, we know that iron 3 and iron 2, they are not existing as same. So the first option where they are saying that both of them high spin, that is wrong. C option, both of them are low spin, that is also wrong. Only among B and D option, you have to check whether iron 3 is existing as low spin or iron 2 is existing as low spin.
B option is correct, ma'am.
Yeah, iron 2 is existing as low spin and iron 3 is high spin. So this option is right. Now please try the fourth. Predict the number of different types of iron in iron 3 Cu12. We already saw that how the structure looks like. So the structure was like this way. In exam, the structure will not come, so you need to know about these things. So how many different types of them are coming? All three are same, two of them are same, all three are different, or none of the above.
Two of them are same.
Where two of them is having two bridging as well as and terminal as well as. Now tell me, for having sigma interaction, following are the required conditions. No change in the symmetry on C2 rotation. There should be head-on overlapping. There should be side-on overlapping. Change of symmetry on C2 rotation. So which of the following options are correct?
Side-on overlapping.
Side-on overlapping is this one. This one. So along the internuclear axis, there is no electron density. So do you think that sigma interaction happens in side-on overlapping or it happens on head-on overlapping? Head means like more electron density along the internuclear axis. So one head and other head, they are overlapping with each other. So you are
Okay,
seeing
head-on overlapping.
So in s orbital also, when we have that pz orbital, so when we draw the pz orbital and s orbital is there, when we say this is a head-on overlapping, so that's why it means a sigma interaction. So head-on overlapping is the one option. Also, when we have this kind of system where electron density is head-on overlapping, so this is your axis. Now, if I rotate it C2 degree, that 180 degrees, do you think there would be any change? So just flip your, if I'm having this one pen and the other pen, and they both are head-on overlapping with each other, right? And now I'm rotating it. Do you think that they're overlapping or the symmetry is changing? Are they becoming like this way? They are still intact, right? They are still along the axis. So what is this called? Is this C2 rotation changed or unchanged? There's no change of symmetry, right, on C2 rotation because they are still along the internuclear axis only. Whatever it was there, you are making a rotation along the axis only. Axis is not like this one. Axis is along wherever your orbitals are there. Whenever they are intact onto the same axis, there won't be any change on C2 rotation. So both the options are right for the sigma interaction. Now tell me, out of all these three ligands, NO2 negative, water, and carbonyl, which one will give you more positive isomer shift? Okay, tell me firstly, which one is more pi accepting or strong field ligand compared to all three?
CO, man.
Cu is the most strong, which is having the pi accepting. After that,
NO2.
NO2 negative is the, and then water. So now tell me which one is going to have more positive isomership for iron complexes.
H2O.
Right. So when we have weak field ligand, which is donating, that will increase the d electron density and that will have the more positive value. So out of these three, H2 is the right. So with that, our lecture ends today with these concepts. I know this is a lot to inculcate and understand. So I would request you to again read or go back and watch this particular video where we have discussed a lot of concepts. And if there is any doubt, then we can have a discussion in the next live session. So is there any confusion till now before I end up the meeting?
Okay, ma'am. No confusion. Thank you, ma'am.
Okay, thank you so much for joining.